Um, Good afternoon to you all. Today we will be talking about IP addressing. That is module 11. It's a very important module, and we have a lot of slides here, so I want you to pay attention a lot. This module is super important. What is an IP address? You have seen an example of an IP address when we were doing binary to decimal conversion. So the topics we expect to treat here today is IPv4 addressing structure, IPv4 unicast, multicast, and broadcast, types of IPv4 addresses, network segmentation, subnet, and IP network, subnetting. In fact, I think this subnetting alone will take us up to Thursday, okay? IPv4 address structure. Guys, this is an example of an IPv4 address, 192.168.10.10. Please, if there is anything you don't understand, stop me, let's go over it. These are very important. This is an example of an IPv4 address. An IPv4 address is divided into two portions. You have the network portion and the host portion, okay? So this is an example of an IPv4 address, and the IPv4 address is divided into two portions, network portion and a host portion. We also have what you call as subnet mask. What is the essence of subnet mask? Or what is the use of a subnet mask? A subnet mask is used basically to identify which part of the IP address is the network portion and which part is the host portion. Okay? Is that clear? The subnet mask is used basically to identify which part of the IP address is a network address and which part is the host part. Remember, I told you IPv4 address is divided into two, network part and the host part. So therefore, the subnet mask will be used to identify which part of that address is called the network part and which part is the host part. Is that clear? Hello? Okay, Ami?
Yes, Uncle.
Yes. So you came late. We are talking about IPv4 addresses. You know, in the previous slides here, are you seeing my screen?
Yes.
So what I was saying is an IPv4 address, this is an example of an IPv4 address, and an IPv4 address is divided into two portions, network portion and host portion. Okay, so subnet mask, the essence of subnet mask is to identify which part of the IPv4 address is the network portion and which part is the host portion. Okay, you can see a subnet mask here, 255.255.255.0. That is a subnet, an example of a subnet mask. If you're looking carefully here, you can see this dotted line here. This dotted line is the division between the network portion and the host portion. Okay, but another thing here is when we convert these things into zeros, you know, the zeros indicate the host and the ones indicate the network. Okay. Is that clear?
Yes.
So we also have what is called the prefix length. Prefix length is a class combustion method used to identify the subnet mask. It's a combustion method. It's a little bit tedious than the subnet mask. The prefix length, you use a slash notation. Okay, you can see here subnet mask 255.0.0.0, but the prefix length is /8. So if somebody should tell you /8, don't be confused, okay? If somebody should tell you /8, it means 255.0.0.0. That /8 means you have 1 H there. You can see them here. This is the entire IP address. The entire IP address is 32 bits long. The first octet is all ones and is 8. That is why you have /8. Okay? If you move to the second one, the first 2 octets are all ones. 8 plus 8 is 16, and then you have /16. The next one is the first 3 octets are all ones. 8 times 3 is 24, so we have /24. You can see. So that is how you move about it. Okay? Is that clear?
Yeah, I got it.
So determining the network using the logical AND. That is, if you are given the IP address and the subnet information, there is a method that you can use to know the network address. Logical AND. Okay? There is a logical AND operator. Okay? You have to use that logical AND operator.
Uncle Yanko, there is noise from the other side.
Yeah, I think GRTS guys. Yes, Tijan. Hello? Tijan. Okay, it's fine, right? So we use the logical AND to be able to determine the network address when we are given the IP address and the subnet mask information. So here you have the IP address as 192.168.10.10. Okay, and then this is the binary conversion. This is the binary conversion. So, and this one is also the binary conversion of the subnet mask information. So you use the logical AND to get the network address. You can see 1 and 1 will
Uncle Yanko, there is still noise.
There is noise there. These are GRTS crew, you know. Sure. I think they have issue with their computer they're trying to fix. Okay. Hello, sir. Okay. Let's go.
Yes, boy, I'm getting you. I'm getting you.
A lot of noise is coming from your end, huh? Okay. So we have the network, the host, and the broadcast. Okay. When we do subnetting, these are the 3 things we are going to have. You'll have a network address, you'll have a host address, and you will also have a broadcast address. Okay? When we get to subnetting. That is why the other time, I think LYC was asking about 192.168.10.0. Why don't we use it? And I told him, that is not for host, that is a network address. You cannot use a network address and configure it on computers, devices, it's not going to work. So the IP address structure has these 3 things: network address, host address, and broadcast address. Okay? Is that clear?
Yeah.
Good. So if you look at this IP address here, 192.168.10.0, that is this, is here. Can you see this?
Can you please increase your decibel? We are not good.
Huh? /24. My connection is not stable. This 192.168.10.0/24, it is the network address. So after you have done your subnetting, your first usable IP is going to be 192.168.10.1. And your last usable IP is going to be 192.168.10.254. The broadcast address is going to be 192.168.10.255. Is that clear? So we have IPv4 unicast, broadcast, and multicast. What is a unicast transmission? Is sending from one host to another host, that is one-to-one. That is called unicast transmission. Sending from one specific computer to another computer, one-to-one. Then we have broadcast. In broadcast transmission, one computer can send to the entire group. Okay? One computer from one to all. Then you have multicast, the final one. The multicast transmission is sending a packet to a group of computers in that network, but not all. Another important thing is the types of IPv4 address. Types of IPv4 address. Okay? We have what you call as public IP address and private IP address. These are the two types of IPv4 addresses. Public IP address and private IP address. The public IP address are defined by RFC, that is called request for comment. It's called RFC 1918. The public IP addresses are globally routable between internet service providers. Only public IP addresses can be routable. That means can go outside to the internet. Only public IP addresses can go to the internet. Private IP addresses are common blocks of addresses used by most organizations. Okay, let's take GRTS as an example. In GRTS, if you look at your computers, I'm sure that all of them are using private IP address. Okay, I'm sure they will all be using private IP addresses. Okay, so private IP addresses are not unique and they can be internally within any network. Private IP addresses are not unique. I can use a particular private IP address in Gamtel and say I can use the same private IP address in GRTS and no problem. But public IP addresses are unique. If I am using a particular public IP address in Gamtel, nobody can use the same public IP address elsewhere. Okay? So, however, private IP addresses are not globally routable. You cannot send packets or whatever information to the network using a private IP address. Okay? An example of private IP address range for class A IP address, private IP address range is 10.0.0.0 to 10.255.255.255. Wherever you see this particular range from 10.0 to 10.255 anywhere, know that it is a class A private IP address. Class B private IP address starts from 172.16.0.0 to 172.31.255.255. This is an example of a class B private IP address range. The class C private IP address range is 192.168.0.0 up to 192.168.255.255. Any questions on this? Any question? No. Okay. If that is clear, we move on. Routing to the internet. How do we send packets into the internet? To the internet? Okay. Here we are talking about network address translation. NAT translate private IPv4 addresses to public IP addresses. I believe in most of your institutions, this is what is happening there, NATing. You use private IP address and NAT it to a public IP address. Because private IP address cannot go to the internet, they are not routable. So you have to do what is called NAT, network address translation. NAT is a very important chapter. You talk about it in more detail, okay? It's very interesting too, okay? Uses, we have special use IPv4 addresses, special use ones. We have 172. This 172 address is called the loopback address. It's commonly used to test an IP. It's commonly used to test TCP IP operation on a particular network interface card. It's called loopback address 172.0.0.1. It's called loopback. You can test your own computer's network interface card to see if it is functioning by sending a ping 172.0.0.1. That is a loopback address. You also have a link local address that is 169.254.0.0. This is called a PIPA address, automatic private addressing for self-assigned DHC. Yes. Huh? Lot of noise, huh? Yes. A lot of noise is coming from your end, huh? So, legacy class full addressing. We have class A, class B, class C, class D, and class E IP addresses. This is the range of class A IP address. Class A starts from 0 to 172. Okay? Guys, are you following? Class A IP address, the class A block starts from 0.0.0 to 172.
Why are we not struggling with internet?
172.
We're struggling with internet, huh?
Is struggling with what?
Okay.
Sir.
At internet. 2585. 333. 555, yes.
Yeah, mute yourself, boy.
But internet, bro.
Huh? Ami, are you getting me? Hello?
Yes, I'm getting you.
Okay. So these are the classes of IP addresses. You need to get them. They are very, very important. Class A, class A, the range of class B, the range of class C, class D, and class E. Okay? They are very, very important. Assignment of IP addresses. The Internet Assigned Numbers Authority, IANA, manage and allocate a block of IPv4 address to regional registries. There is a body that is called IANA. IANA is responsible for the assignment or the allocation of IP blocks to other regional registries. Regional registries are the ones that are responsible for different regions. Like in the case of Africa, we have a body called AFRINIC that is responsible. And that AFRINIC is answerable to IANA. What is wrong with this? Let's go. Okay. In the case of Africa, it is called Afrinic. And in Asia, you have another one called Apanic. Then you have another one here in maybe North America or South America. So they all have their different bodies that are responsible for the internet. Network segmentation, broadcast domain, and segmentation. What is a broadcast domain? Okay. A broadcast domain is an area of the network where a particular broadcast will be heard in that network. So this area is a broadcast domain, an interface of a router, because a switch does not break a broadcast. So the entire network connected on a switch is a broadcast domain. Okay? Each router interface connects to a broadcast domain. You can see this is a router interface. It connects to a broadcast domain. Problems with large broadcasts. There are a number of problems that can happen if you have a very large broadcast, because a lot of computers will be sending a lot of broadcast information, and that can result to a network degradation or very slow performance of your network. Okay? Because anytime a particular computer sends a broadcast, all the devices in that network will be affected. They will get the broadcast. So if your broadcast domain is big, you are trying to attract a lot of trouble, network congestion in your network. So reason for segmenting network, it reduces overall network traffic and improve performance. If you segment your network, that can result to a better performance of your network, and it can also result into better security of the network. It can help in terms of security. So that is why, people will have to segment their network to avoid a lot of network devices being in one group.